Welcome to online math class. Today's section is section 11.2, permutations. All right, permutations is the ordered arrangement of items that occurs when no item is used more than once and the order of arrangements makes a difference. So let's go ahead and take a look at the first example here. You need to arrange 7 of your favorite books on a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? So what they mean is, this is one order that you see. Now if I move the yellow all the way to the front, that's the other order. If I move the purple all the way to the back, that's another order. If I move the green, that's another order. If I move the yellow back again, that's another order. So it's not possible for you to go ahead and keep playing with this and then write down, correct? So how do you deal with this mathematically? So let's go ahead and see. The shelf can take 7 books. So I have 7 spots right here. So if I have to place the first book, how many options do I have? I have all the 7 books available, right? So for me to go ahead and place or pick the first book, I have 7 options. Remember, I have to pick each and every book. Now, once I pick the first book, I'm going to go ahead and erase this line here. So let's say I pick the first book. So the first book is, let's say, orange. I'm going to go ahead and erase orange. The first book is placed in orange. Orange is gone. Now for the second one, how many options do I have? I have 6 options. Now let's say I picked already 1. Now for the next one, how many options do I have? 5 books are left. Okay, so 1 book goes to the shelf. The next one, 4, because I only have 4 books to pick from. That's gone. Now the next one, 3. So I'll go ahead and pick a yellow. Now that's gone. How many options do I have now? 2. Okay, 1 book is gone. How many options do I have for the last one? 1. So now all the books are placed on the shelf. What now? Remember, you have to pick the first book and the second and the third and the fourth and the fifth and the sixth and the seventh. Okay, so now when I go ahead and multiply this one, 7 times 6 times 5 times 4 times 3 times 2 times 1, I'm going to go ahead and do that here. So I have 7 times 6 times 5, right? Yeah. 5 times 4 times 3 times 2 times 1. And my answer is 5040. So my answer is 5040. Again, quick recap of what we did. The first space or the number of ways I can pick the first book is 7. Once the first book is done, the number of ways I can pick the second book is 6. The number of ways I can pick the third book, fourth book, fifth book, sixth book, and the 7th book. Okay? Now let's go ahead and look at the next one. There are 5 performers who will present their comedy acts this weekend at a comedy club. One of the performers insists on being the last stand-up comic for the evening. If this performer's request is granted, this is very important here, how many ways are there to schedule the appearances? I always write down so I can see what's going on here. So I'm going to go ahead and draw the performers. So he's one performer. He or she is the second performer. And I have the third performer. Let me change the color. I have the 4th performer. I'm going to put them right here. And I have, let's see, a 5th performer. Okay, and let me see how many spaces do I have. 1, 2, 3, 4, and 5. So there are 5 performers and they all want to perform in different ways. But one of the performer wants to perform last. Okay, so let's go ahead and see who wants to perform last. Let's say the blue guy wants to perform all the way in the end. So that spot is taken. Now let's go ahead and see how many ways can the others perform. So how many ways So how many ways can they perform is the question, correct? So somebody goes first, somebody goes second, somebody goes third, and somebody goes fourth. How many options do I have for number one? How many people can go and play number one? How many options do I have? 4 performers. Any of the 4 can perform first. So for the first part, I have 4. So what I'm going to do is I'm going to go ahead and bring the green guy. Let's say the green guy is performing first. Now for the second place, how many options do I have? 3. Do you see that? So I'm going to go ahead and bring this dude. Oops, his head is cut off. I'm going to go ahead and bring this dude right here. Now for the next option, for third place, how many do I have left? So I have 2 performers that can go in third place. I'm going to go ahead and bring the red performer here. How many are left? Only 1. So he or she will perform. So now if I only look at the numbers, here, so I'm going to take off the places. If I only look at the numbers, in the first place, I have 4 ways they can perform. The second place, I have 3 who can perform the second, 2, and 1. So it's 4 times 3 times 2 times 1, which is 24 ways. Quick recap. Because the last position is taken already, that person is gone and that position is gone. We only have 4 positions now. So for the first position, I have 4 options. For the second, I have 3 because the first one's taken, 2 and 1. And you simply multiply all of those. Okay? Now let's go ahead and look at what it means by factorial. Factorial is simply multiplying the number through 1, down to 1. So if I say 7 factorial, it is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's what it means by factorial. Now let's go ahead and look at an example here. It says evaluate without your calculator, but I would like you all to use your Desmos here. So I'm going to go ahead and do this without the calculator first. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5, 4, 3, 2, 1. 5 and 5 cancel, so I'm going to go ahead and do the math here. It is 8 times 7 times 6. So if I go ahead and plug that into the calculator, 8 times 7 times 6, yes, I have 336. So this is 336. Okay, now for the next one. When you have big numbers like this, I always want you all to use your Desmos. So let me show you how to do that in your Desmos. I'm going to clear everything. Remember, my question was 26 factorial over 21 factorial. Is that right? Let me check. Let me cross check. Yes, 26 by 21 factorial. So you first go to functions and you see this symbol right here. That's your factorial. So 26 function, press this symbol all the way below the last symbol. Go back to your main, divided by 21. Go to your functions again and click factorial. So 7893600 is your answer. There's no way you can do this with your hand. This is 7896600. I think there was one more 0. Okay? So I want you all to use your Desmos calculators as well. Now let's go ahead and see formula for permutation. And again, we're going to use Desmos for this one too, so you don't have to do anything manually. The number of possible permutations of R taken n items at a time is NPR. What that means? Let's go ahead and do example 5. You and 19 of your friends have decided to form a business. The group needs to choose 3 officers: CEO, operating manager, and treasurer. In how many ways can these offices be filled? You and 19. So totally there are 20 people. So from 20 people, you have to choose 3 of them. And what does the formula say? The formula says NPR. That means you're choosing R from N. So the number of ways you can choose 3 people from 20 people when the order does matter. Because there's a difference when you are a CEO, I am an operating manager, and I am a treasurer. That's one arrangement. I can be the CEO, you can be the operating manager, and your friend can be the treasurer. That's another arrangement. So here, arrangement does matter. So when arrangement matters, you use P, okay? So that means from 20, you're choosing 3. That is 20P3. And how do I do that in my Desmos? Clear? So when you go to your Desmos, you'll go to the main thing. You have abs, ABC, and functions. Click on functions and click NPR. And go back to main, 20, comma, 3. 6,840. So how many ways can you choose? 6,840 ways. Okay? Now let's try one more. A club with 6 members is to choose 3 officers. So president, vice president, and secretary. Whenever they tag you with an officers or, a cadre, the order definitely matters. Okay? In each office is to be held by one person. No person can hold more than one office. So every time you do a problem, you need to ask yourself a question. Does it make a difference who's a president, who's a vice president, who's... Yes, it does, because the order does matter. So you are choosing 3 officers from 6 when the order does matter. So it's a P. 6P3. Let's go ahead and do that in Desmos. Clear. Function. NPR. You go back to main. 6, comma, 3. And that is 120. Just for the sake of it, I want to show you all how it's done mathematically too. So 6PR is 6 factorial. If you go back to the formula here, 6 factorial divided by 6 minus 3 factorial. So that is 6 times 5 times 4 times 3 times 2 times 1. 6 minus 3 is 3 factorial. 3 factorial is 3 times 2 times 1. So 3, 3, 2, 2, 1, 1. That gives you 120. So 120 ways you can choose 3 officers from 6 people. But please use your Desmos while you're doing your homework and your test. In a race, so when it's a race, by default, order matters. Who comes first, who comes second. So I know I'm using my P here. So these are the keywords. Race, so it's a P. In which 6 automobiles, so 6 automobiles are entered and there are no ties. In how many ways can the first 3 finishers come in? So again, I'm trying to see how many ways 3 of them can compete from 6. That means I'm choosing 3 from 6 where the order matters. So it's 6P3. And we saw 6P3 from the previous problem is 120 ways. Okay? Example 8. The way you need to do this problem is, as soon as you see your example, you have to pause, read it, and then play. For a segment of radio show, disc jockey can play 8 records. There are 11 records to select from. In how many ways can the program for this segment be arranged? So does the order matter? yes, the arrangement does matter. If he plays my song first and your song last, that's a different arrangement. If he plays my song second and your song seventh, that's a different arrangement, right? So what am I doing again? I am picking 8 from 11 where the order matters, which is 11P8. So let's go ahead and do this in Desmos. Clear, function, NPR, go back to your main, 11, comma, 8. 6652800. So that is 6652800. Okay? All right. Now, in your assignment, there are a couple of problems where they ask you for different kinds of operations, not just division operations. They're asking you about subtractions of permutations too. So I'm going to go ahead and open one of them and go ahead and show you all how it's done. Not this, not this. Okay. So in your homeworks, they ask you problems like 5 factorial minus 2 factorial. So you can simply plug it into your calculator and you have it. And let's see the next one. And there's one question that has, let's say, open parentheses, 8 divided by 4, close parentheses, oops, not that, close parentheses, and they say factorial. So you have your answer. So every time they say factorial, please go ahead and use your Desmos calculator. And the way it's done is you are in main, you go to your function. This, when you click the exclamation, that's your factorial. Clear all. NPR is NPR. You go ahead and plug in your numbers. The n goes first, so that is the bigger number goes first, and then followed by the smaller number. Okay? Hope this helps.